Welcome back to the Dargslan series. We're now 12 parts into our Linux journey, and today we're stepping into something that genuinely changes how you work. This part is all about SSH and remote access, the skill that lets you sit at one machine and operate another as if you were right in front of it. Think of SSH as a universal remote control. Once you're comfortable with it, any Linux box on the network, across the room or across the world, becomes just another terminal window. Here's the path we'll walk together. We'll start with what SSH actually is under the hood, then make our very first connection and decode that mysterious fingerprint prompt everyone sees the first time. From there, we'll graduate to SSH keys, leaving passwords behind, and set up shortcuts so you never type a long hostname again. We'll finish with the practical day-to-day stuff, moving files with SCP and rsync, and bending network ports through tunnels. So let's start with the basics. SSH stands for Secure Shell, and the idea is beautifully simple. Your local machine runs an SSH client. The remote server runs a daemon called SSHD listening on port 22, and between them runs an encrypted tunnel, typically using AES. Three things make this powerful. It's encrypted, so anyone snooping on the network just sees gibberish. It's authenticated, meaning the server proves it really is the server you wanted, and you prove you're really you. And it gives you a real shell, not a clunky remote desktop, just bash with all your usual tools, exactly as if you were sitting at the machine. Now let's actually use it. The command is just SSH, then your username, an @sign, and the host name or IP of the server. Exactly the same shape as an email address. The very first time you connect, SSH will stop and show you a fingerprint, which is basically the server's unique ID card. That warning isn't a bug. It's SSH asking, "Hey, I've never met this machine before. Are you sure it's the right one?" Ideally, you check that fingerprint with whoever runs the server. Type yes, enter your password, and you're in. Greeted by the remote shell prompt as if you just sat down at the machine itself. But typing that password every single time gets old fast, and honestly, it's the weak link. A short password can be brute forced. You probably reuse it across machines, and there's no clean way to plug it into a script. SSH keys flip all of that on its head. They're mathematically uncrackable in any practical sense. You connect with no prompt at all, and if one machine gets compromised, you just revoke that one key instead of changing your password everywhere. Once you've tasted that, you really don't go back. So how do keys actually work? You generate a pair of files that live in your hidden SSH folder. The private one, ID ed25519, never leaves your laptop. You guard it like a house key, lock it down to permission 600, and never email it, never copy it, never commit it to Git. The public one, ending in .pub, is the opposite. You can paste it anywhere, and it goes into a file called authorized keys on every server you want to reach. When you connect, the server uses that public key to challenge you, and only the matching private key can sign the right answer back. That's the whole trick. Now let's actually do it, in 3 quick steps. First, run ssh-keygen with the ed25519 flag. That picks the modern, fast, secure algorithm. And just press enter through the prompts to accept the default location. Second, hand your public key to the server with ssh-copy-id. It logs in once with your password and tucks the .pub file into authorized.keys for you. Third, connect again, and this time no password. If your server doesn't have ssh-copy-id, the little tip at the bottom shows the manual pipe that does the same job. Once you're logging in without a password, the next annoyance is typing out long ssh commands. That's where the ssh-config file comes in. Open up ~/.ssh/config and define each server once, its hostname, your username, the port, even which key to use, and give it a short nickname. From then on, ssh-prod just works, instead of that mouthful with -p and the full address. You can even use wildcards like star.dev.example.com to apply settings to a whole group of machines. And there are some real gems hiding in the options. proxy jump hops you through a bastion host automatically, server alive interval keeps idle connections from dropping, and forward agent carries your keys along for the ride. We'll lean on a few of these in the next slides. And notice how nicely those nicknames pay off here. Once you've defined prod in your config, copying files becomes almost trivial. For quick, one-off transfers, SCP behaves just like CP, only the destination lives across an SSH connection. Handy for shipping a single file or pulling a log back down with that trailing dot meaning right here. But when you're moving a whole directory tree or running it again and again, reach for rsync. It's smart enough to send only the bits that actually changed. It can resume after a drop. And with flags like -avz, it preserves permissions, shows progress, and compresses on the fly. Rule of thumb, SCP for a quick toss, rsync for anything you'll repeat or anything large. Since I just mentioned -avz, let's actually decode it. The A is archive mode. It bundles together all the things you usually want preserved. Permissions, timestamps, symlinks. The Z compresses data on the wire, which really helps over slower links, and V just makes rsync chatty so you can see what's moving. Add, delete when you want the destination to be a true mirror. Files removed from the source disappear on the other side too. And for big transfers, H and progress turn the output into something a human can actually read while it runs. Now let's talk about one of SSH's most underrated tricks, port forwarding. With -L, a local forward, you tell SSH, take this port on my laptop and pipe it through to something the remote server can reach. So typing localhost 5432 on your machine actually hits the database over there. -R flips it the other way. A remote forward exposes something running on your laptop so the server or a teammate logged into it can reach back to you. Same tunnel, just pointed in opposite directions. With the basics down, let me hand you a few tricks that separate casual users from people who really live in SSH. You can append a command in quotes to run something quickly without ever opening a shell, or redirect a local script straight into SSH and have it execute on the other side. No copying needed. -A forwards your SSH agent so you can get clone private repos from the remote as if your keys were there. If a session ever freezes, type ~. at the start of a line and you're out instantly. -J hops you through a bastion in one transparent step, and -X even lets remote graphical apps draw on your local screen. Now, before you go off being clever with all those tricks, let me warn you about 3 mistakes I've watched people make again and again. First, never share or copy your private key between machines. That key is your identity, so generate a fresh one on each laptop or server and use ssh-copy-id to spread the public half around. Second, SSH is picky about file permissions. If your SSH folder or keys are too open, it will silently refuse them, so remember 700 for the folder, 600 for private keys, 644 for the public ones. And third, please don't leave root login with passwords enabled. Bots are hammering port 22 right now guessing passwords. Disable root login, disable password auth, and stick to keys. With those warnings tucked away, here's a little cheat sheet, the handful of commands that, honestly, will cover 90% of your SSH life. SSH user a host to drop into a remote shell, ssh-keygen to make a fresh ed25519 key, and ssh-copy-id to plant it on a server. For files, SCP moves a single one across, while rsync AV is your smarter friend for whole directories. It's resumable and only sends what changed. And SSHL is your tunnel, pulling a remote port down to localhost. Screenshot this one, you'll come back to it. So let's pull the whole part together into 5 things worth remembering. SSH is your universal remote, encrypted, authenticated, and scriptable. Keys beat passwords every time, and your private key stays put while only the public half travels. A small SSH config file will save you years of typing, and when you're moving real volumes of data, reach for rsync instead of SCP. Hold on to these 5, and you've got the foundation for everything remote in Linux. And that's a wrap on SSH. Next up in Part 13, we shift from getting into your server to protecting it. Firewalls and security basics with UFW firewalled and fail to ban. You're officially halfway through the course, 12 down and 12 to go. Take a short break, then I'll see you on the other side as we lock the front door behind us.